Welcome to MrCScience.com's video on elements and compounds. We're going to talk about the basic building blocks of chemistry, the element and the compound. Well, let's start out with the element. What is an element? Per your book, an element is any substance that cannot be broken down or decomposed into a simpler component. So let's take a look at this. Okay, so here's copper. Copper is an element. Symbol Cu on the periodic table we'll talk about in a minute. So copper is made up of a bunch of atoms of copper. So if we take that copper and divide it in half, we still got copper, just half as much. If we take that and divide that in half, everything's still copper. If we if we continue to divide it in half until we're down to one atom of copper, it is still copper. It still has the same color, the same properties as the original copper. If we take that last piece of copper and divide it in half, then we create nuclear fission, we release energy, and it's no longer copper. So an element is something that can continually be divided down to you get down to the one atom of it, and it's still got the same properties. Now let's look at compounds. Let's take the compound sodium chloride, also known as table salt. It's what you put on your French fries. Sodium chloride's atoms are arranged in this formation. They form little squares, little cubes. That's why when you look at table salt really closely, you see little cube forms. So what happens if we divide sodium chloride in half? We just get a smaller amount of sodium chloride. If we do it again, we get yet smaller sodium chloride. If we do it again, we get one molecule of sodium chloride. If we further divide that, then things get interesting. So sodium chloride is made out of sodium atom. Na is sodium. And the chlorine atom. Cl is chlorine. Sodium is a explosive metal. If you drop it in water, it will violently react. Chlorine is a poisonous gas. So if you take explosive metal, combine it with a poisonous gas, you get something we put in our French fries and eat. So it is a compound. So you hit a point where you divide it, and really you only get one chlorine here. But if we went like that, but chlorine is what you'll find later is a homonuclear diatomic. It quickly combines with another chlorine, and you get Cl2. So a compound can be divided to a point where it's no longer the compound. So this molecule of sodium chloride has different properties than these atoms of sodium and chlorine. So that's the compound, the difference between the element and the compound. So let's look at our elements and how we know what they are. We use the periodic table of elements. Now this, you've probably seen this before, it can be a little daunting. We are going to get to know this very intimately. You're going to understand why. So why is it this weird shape and not just a rectangle? There's a reason for that. You're going to understand that why. You're going to understand what these numbers above and below mean. You might have got a little bit of that in physical science, I think. But we're going to go into that much more in depth and how the atoms are made out of their protons, neutrons, and electrons, and where they live more specifically than just shells around the interior of the atom. So you'll learn that as we move forward. So we're going to get to know this a lot more. One main thing that you can tell, if you look down here, our reds are our nonmetals. Every other color is a metal, be it standard, transitional, or intertransitional. All those are metals. What's the difference between a metal and a non-metal? Well, metals tend to be or are usually malleable, which means you can bend them. Sometimes you got to use a hammer, but they won't break, they'll bend. Metals have luster or are shiny, and they're able to conduct electricity, especially in solution. So metals are like that. So all these metals tend to be shiny. A few that you know, aluminum, metal, iron, metal, nickel, copper, silver, gold, tin. Those are all shiny metals that you're familiar with. Some metals aren't necessarily what you consider a normal metal, like calcium. You think of calcium as kind of a whitish color. Sodium's kind of white as well, but they're all metals. A non-metal are Reds in our jagged line here denote nonmetals. Nonmetals, of course, aren't malleable. They tend to be brittle. They will break. Um, they, where is it? Yeah, they break easy. They lack luster, so they're not very shiny. And they do not conduct electricity. So take a couple: sulfur, yellow powder; carbon, a black substance, things like that. Uh, Chlorine, kind of a greenish colored gas. So all these are nonmetals. Now you'll notice that they all kind of live right here except for this one. Hydrogen over here lives way over on this side, but it kind of belongs with this group, so that's why they're. So you need to know that hydrogen is a nonmetal. If you think of hydrogen, it's a odorless, colorless gas that makes your voice sound funny. It doesn't have luster. It isn't malleable, although in a way it is, because we don't really work with it in any other way than gas. But so, and you don't know, but it does not conduct electricity, although it can. That's something coming forward. But hydrogen is considered a non-metal as well as everything on this jagged line. You'll have to know about this jagged line and the metals versus the non-metals. Okay, if you have any questions on any of this, rewatch the video. If you're still curious, drop me a line at Mr. C at MrCScience.com. Thank you.